Hello, welcome to Decidedly Retro. I'm Steve. This channel is about fixing old computers and other hardware stuff from old systems. Today we are looking at the Dallas clock chip and how to remove the old battery that's built in and replace it with a CR2032 socket. These are found in lots of PCs and especially things like Unix workstations such as the Sun Spark stations and Ultra systems. In this case, it's a clock chip from an NVRAM chip from a Sun Spark Station 2. So let's get to the bench and have a look. Here are the two chips in detail. You've got two types of packaging here. So you've got the original type here, which has got the battery, try and focus, the battery on the top with a, if I can get something underneath, you can see there's actually a gap between the chip and the potting compound. You can look at the chip itself. You can see pin 1 is at this end, and if we look between there, you might be able to just make out that at this end there is a larger amount of the space is being taken up, because that's the battery end. Battery is at the opposite end to pin 1. At pin 1 end you have the oscillator. With the second type, possibly newer type of enclosure, the chip is in a plastic surround, which makes it slightly a bit more difficult to actually take off using this heat technique, because it means more prying between the chip and the, if I can get a good, let's move this out of the way, that's better. There's more, you need to do some more careful prying between the chip and the plastic case, but the technique will work just as well, but it's just more difficult. So today I'm going to work on this older version because it's easier. First of all, I'm going to put the chip into a sacrificial socket to protect the pins, because otherwise during the manhandling there will be some bent, and some of them bent, and that's definitely not what you want. So I've just put it into a, in this case, a 28 pin. It should be a 26 pin, but hey, 28 pin socket, just to protect the legs, so I can actually just bend these in out the way because it's easier. I'll get my screwdriver, because I can use to pry between the two things. And now I'll use my heat gun. I've set it to being 150 degrees C. Now, literally, all you have to do is try not to burn your fingers and heat the resin. Oh, of course it's going to be difficult. Heat the resin until it should start to turn slightly white. This may take some time, because the resin slowly dissociates and becomes brittle. Well, it becomes like hard cheese. Well, cheddar that's been left out to the fridge for about a week. So it's actually a lot easier to to break apart. But you've got to make sure that you heat the resin evenly and completely. Don't know if you can start to see, but some of the package is starting to go white. Let's shift it a bit so you can see better. I'm just going to slowly warm this up using the 150 degrees C heat air. This may take some time. It's important to warm the resin right the way through, because otherwise you won't be able to break it easily, and you're also liable to damage the leads for the crystal, especially the crystal, which is the most vulnerable. Right, let's see if that's any good. So I don't know if you can see there, but the package slightly changed colour. Let's see if we can break. It's starting to go, but I don't like the way that it's lifting the whole package out. Unfortunately, in this case, it's not breaking here, it's just lifting the package up. Or maybe it's working. Got to be very, very careful, especially at the pin one end, because that's where the fragile crystal connections are. Here we go. Actually, that's the crystal coming out. Just got to be careful about the leads. And there we go. We've got the crystal out. Now it's just a case of trying to get the battery. Right, I'll rewarm that and see if we can get that end. It's probably that the battery has taken a lot of the heat, and so the resin hasn't fully broken down. Trying to do it so you can see. There we go. Getting this so that you can see what I'm doing. I've just nibbled away at the resin, the potting compound, and that should now be able to be levered out. Come on. Just put my headlamp on so it's about to see more easily. See, now that's been heated, just breaks away. And get underneath the battery, should be able to lever it out. Take this out of the way. It's nothing to come. There we go. Right, as you can see here, we have the battery, and unfortunately one of the legs is disconnected, but that shouldn't be a major problem. We just need to clean out the potting compound in this area here where the connections are. You can see the solder joint is just broken. Just stab myself with the socket. So just need to clean out. Just take that off completely. There we go. And this is why you've got the sacrificial socket at the bottom. You can now, I can now use a tool without worrying about the connections. Excuse the blood. Not really hot enough. So now I should be able to break out this. Now if you see there, let's try and focus. On focus. There we go. Almost. There we go. You can see that you've got the two connectors there onto which we can fit a new battery. And the most important thing is the crystal is safe. So this is the original battery. As we can see, we have two leads. The top one here is the positive, bottom one the negative. That sat on the battery, on the chip, like that, which means that that side is positive, that side is negative. And I've marked that with a Sharpie so that when I fit the new battery, I don't put it the wrong way around. What I'm going to use today for the battery is a PCB mount 2032 socket. Of course, I can't put that directly on there, so I'm going to fold over the pins and solder some wires onto there, and then solder the wires onto the two connectors here, and just basically hot glue that on the top. That's the quickest and easiest way. You can always, if you've got a 2032 holder that's got wires on that's separate, that's easy enough. Just solder those on and stick it up somewhere else on the motherboard, wherever you're going to put the clock chip. So I've cleaned up the contacts on the chip, and now I can solder these wires onto here. Making sure I've got the right polarity. There's one. Oh, come on. There's the other. And now I can just put that over there, use some hot glue and put it onto the top. And that's it. That's all that's necessary. And as you can see, the crystal oscillator and the crystal is fine at that side. Right, time for the hot glue. Let's put a huge blob because I want to fix the crystal in place as much as anything. So let's get this on top there and try not to stick myself to it. And that's not impinging any of the legs. The crystal is nicely encased in hot glue, so that's not going to go anywhere. Right, let's take it out of the socket. As you can see, we have quite a neat replacement for putting the battery on.